Hello everybody. Thank you for attending this workshop. My name is Faraz. I'm one of the main organizers at Summit. Just a quick message that you would have received an email yesterday around 9 p.m.ish for you to get the link to the conference tomorrow. It's going to be from Hopin. If you have not received it, please check your junk mail. We're also going to be sending a reminder later the afternoon today. There's also going to be a reminder later tomorrow, early morning. So if you have not received it so far, please do check your junk mail. We are very excited to host this workshop. I'm going to hand this over to Ayesha, who will further run the workshop. So thank you, everybody.
All right, thank you. So for anyone who doesn't know, I'm Ayesha. I'm a machine learning engineer at Filament North America, and today I'll be giving you a walkthrough how we at Filament use applied machine learning to fast-track chatbot training. But before I dive into that, I'd like to give you a bit of motivation, what the motivation was behind the work. So as you know, chatbots have been gaining a lot of traction over the past couple of years. It is only recently that we're seeing their actual value, where amidst the current pandemic situation, a lot of the contact centers have been seeing a surge in their call volumes, and they're turning towards chatbots as an effective means to disseminate information to their customers or users. And while it is important for these chatbots to be in production very quickly, it's just as important for these chatbots to perform well. So our experience at Filament with over 65 conversational AI projects sort of gives us an insight on what those success factors are. And it literally boils down to two things. You need to have a comprehensive set of intents when you're designing your conversations. But not only that, you also need to provide each intent with a comprehensive set of utterances. So for anyone in the audience who's not familiar with the terminology, an utterance is a phrase that a user would communicate to the chatbot, and an intent is the action that the user wants the chatbot to perform. This is what the chatbot development process looks like at the current state. You can see that conversation design and testing and reiteration are the two most time-consuming work streams, namely due to intent identification and the utterance training process. So this is what the view for a conversational designer would look like. They would have to input an intent into this UI and then provide this software with a sample input utterance along with an example of how the chatbot should respond to the user. And for each of the utterances, they should provide the chatbot with a list of, for each of the intents, they should provide the chatbot with a list of utterances that reflect how the real world user would communicate with the chatbot. Now you can see that as your conversations grow more and more complex, this task of manually inputting utterances and intents is not very scalable. So let's jump into the intent identification process. Now, a starting point for a lot of conversation design is unstructured data, whether it's in the form of chat log conversations from an existing texting service, social media comments, or even emails. And for your conversational designer to sift through these large amounts of text data, it could be very slow and time-consuming, but also unreliable. So our objective here was to use natural language processing techniques along with unsupervised learning to be able to group this large, unstructured conversational data into intents. And we're going to do this based on semantic similarity. Our approach was first to start off by simple text preprocessing, which involved converting these messages into lowercase, removing special characters, removing stop words, and systematizing these tokens. And once you've had a list of tokens, you pass these tokens through a term frequency inverse document frequency vectorizer, which is a commonly used technique for information retrieval when you want to detect keywords that are relevant to your document. And so once you've done that, you end up with a sparse set of vectors with dimensions that are equal to the vocab size. And for you to basically not only improve the model performance, but computation of your machine learning model, you need to perform dimensionality reduction. Now, once you have these new reduced vectors, you can pass them through a clustering algorithm. In our case, we use a hierarchical clustering algorithm where each observation started with its own cluster and was iteratively merged into clusters based on a distance metric, where in our case, we use the cosine distance since it performs well on highly dimensional data. Now, after the clustering exercise has been done, it is important that you visualize how well separated your clusters are using a tool like TSNE, which reduces the dimension of your TF-IDF vectors into 2 dimensions for easier visualization. And it's also important that you manually inspect the clusters to see how well your algorithm has performed. Now, through this technique, we were able to group intents based on their cosine similarity, and most part, the resulting clusters were cohesive. However, we did notice that some of the clusters contained different set of topics that were related to each other. So for example, discussions about school or discussion about their relationship with parents, those were grouped together. So as future improvements, we recommend using a clustering approach that uses context-aware sentence embeddings. An example of such a model that could give you that is the universal sentence encoder by Dialogflow, and then couple that with a semi-supervised learning approach to separate these larger clusters into smaller clusters that contain separate topics. And that leads us to the utterance training phase. Now, a lot of the like when you're training your chatbot with different lists of utterances, you need to make sure that these utterances are reflective of how the real world user would interact. The performance of your chatbot is not only dependent on the quantity, but also on the quality of these utterances. And what I mean by quality here is your list of utterances should be syntactically diverse, should have different sentence lengths, so it's able to capture and perform well in production. So our objective here was to develop a language model that when given a sample input, it can autonomously generate utterances that are not only syntactically diverse, but they do still maintain the same degree, a similar degree of semantic similarity, meaning you want your language model to generate paraphrases from a simple sample input utterance. Now, language modeling enables us to do that since it learns the probability distribution of sequences in your training corpus and then produces an output that's sampled from that same distribution. And the evolution of sequence-to-sequence models from autoencoders to transformers through the discovery of attention mechanisms were able to produce state-of-the-art results in language generation tasks. A couple of examples of these transformer-based models are BERT and GPT-2. Another concept borrowed from the field of computer vision in NLP is transfer learning. And what transfer learning basically does is you can train your language model on a very generic text of large corpus of data like Wikipedia for it to be able to gain an understanding of the English language, the how to form coherent sentences, and then you can train it on a smaller subset of task-specific data sets, and this, be it a question and answer data set, a text summarization data set, to fine-tune it for that downstream NLP task, which then produces a final model that you could use. In our case, we use the GPT-2 language model, which is a decoder-based language model trained on 40 gigs of internet text. It was trained with the objective of predicting the next word in the sequence when given an input sequence. It is able to form coherent sentences, but it is also able to have an understanding of different topics and different domains. And this is very crucial when it comes to paraphrasing. There are a couple of variants for this GPT-2 model, starting from the smaller model that has 124 million parameters, to ranging to the largest model that has 1,542 million parameters. And the choice of which variant you want to use basically depends on how much training set you have for the fine-tuning task. The data set we used we wanted to sort of preserve the diversity, or we wanted that data set to have the same characteristics as we want in our high quality paraphrases. So the data set we used here was the Quora question pairs data set, the Microsoft Paraphrase Corpus data set, the SICK data set, and multi-NLI data set. And all of these data sets are basically have sentence pairs extracted from different sources. For example, Microsoft Paraphrase Corpus was extracted from news articles, and multi-NLI data set had written and spoken text sentence pairs that qualified as paraphrases. So our approach here was to build a training corpus of sentence pairs, which involved a wide variety of written and spoken texts from various domains. It is important that your corpus for fine-tuning is large enough so your language model does not overfit to these sentences. And then you would basically pre-process the training data to indicate special tokens for start and separation of these sentence pairs for it to be ingested by the model like GPT-2. And then you run the model through a fine-tuning process for that task. It is important that during the model's running, you validate the results at different checkpoints to see how your model is performing. Once you're happy with the fine-tuned model, you can use it for inference, where you could provide in an input sentence and generate paraphrases from it. These are a sample of utterances that we provided to this paraphrasing model, and along with a sample of paraphrases that it generated. You could see how it's associated severe illness with becoming sick, severe medical problems, and even diagnosis. This is another example of where we gave it an input sentence. You could see even how the syntactic structure of the paraphrases vary. You could see how the sentence length also varies. And so just to summarize the results, for the most part, the model was able to generate good quality paraphrases. You could see how it picked up on context because it was pre-trained on Wikipedia text. While we do understand that some of the paraphrases were very close to the input sentence and they wouldn't significantly add or improve the performance of a chatbot, we think that we could use a mechanism like similarity scoring to filter these out when we're training the chatbot. As next steps, we want to explore the possibility of introducing a feedback loop where the user can either qualify or disqualify paraphrases, and then the model can use that input from the user to retrain. Now, just to wrap things up, this shows how the current, if we were to integrate tools that we've mentioned for intent identification and utterance training into the chatbot development process, this is how the time savings would look like. And while there are a couple of different ways we can improve or optimize those two models, we believe that our efforts should now be focused on engineering such tools into chatbot development framework. And thank you. That concludes my presentation, and I'll be taking any questions.
Thanks, Ayesha. So it looks like the questions are in the chat.
How do you create a bag of words or dictionary like a Q&A at the first spot? Could you elaborate? SFA, I don't know if I pronounced your name correctly.
Hello?
Yes. Hey.
Yes, can you hear me now?
Yeah.
Actually, I'm about to do that, but I have problem with creating the bag of words for myself. I'm not sure how to create it, like Q&A. Like there are questions and answers, but I'm not sure from where can I get it. Like, is there any source that I can get the Q&A, or for every business is different, right? So that's my question.
I think there are corpuses or data sets that have question and answer mappings, and you could use that. Regarding the bag of words, you could actually use a bag of words model to get the highest, get a count for the highest frequency of words, and you could sort them by frequency and filter out anything on the edges of that. So anything that's like appearing in more than 50% of your text, and anything that any tokens that are very rare occurring, and you could use that as an input to your model.
Yes, but do you have an example for the data sets?
I don't have any on the top of my head, but I could definitely forward some to you if you reach out to me.
I really appreciate that. Thank you very much.
The next question is by Juan. What is the target of the model? Juan, can you elaborate which model you were talking about?
Hello?
Hello?
Can you hear me now?
Yes.
Yeah, so I'm just curious, when you said like you train a model with, so you have a data set, you have a pair of utterances, right? And then you feed that to the model. So what is the target for that model?
Can you emphasize what you mean by target here?
So I'm trying to understand the problem. So you have a data set, right? Which means that so you train. So the input is the pair of utterances, and what is the output, or?
Yeah, so the target of the model is for when you're giving it an input sentence to generate a paraphrase of that input sentence. So the data set that you're training it on is a sentence pair of paraphrases. And it sort of gets, that the objective here is for it to learn that task of paraphrasing based on generate paraphrases when provided with an input sentence. Does that answer your question?
I'm still a bit confused, but I think it's fine. Yeah, we can just move on to other questions. Thanks.
Okay. Does the model validation have to be done by hand, manually looking at outputs to see if they're good or not? In the case of language generation, yes. You can obviously save different checkpoints as you're training them, and also log the paraphrases that are generated at each checkpoint. And then you can use that to assess. I mean, specifically for paraphrasing, there is no known metric or no single metric that you could use to evaluate how well your model is doing. Because it's such a complex task, you have to account for syntactic structure. You also have to account for semantic similarity, which you could do by cosine distance, but there's no one metric that you could use to, or there's no agreed upon metric that you could use to evaluate it objectively. So moving to the next one, what tool do you use for your conversational assistance and why? Dialogflow versus Watson. So we actually have a chatbot development product called EBM, which in the background is integrated with Dialogflow or Watson. There is no preference. Usually it's more dependent on the client and what their preference is, and which NLU provider would they go with. How do you compare TensorFlow and GPT-2 model for the chatbot? Is that Asafit again?
Yes, it's me again. Yes, I was about to read an article about how to create a chatbot. So on that article, they use TensorFlow. I was wondering what is the differences between GPT-2 and TensorFlow for like chatbot modeling?
Well, TensorFlow is just a framework to develop machine learning models. GPT-2 is the model architecture of the language model. It can be implemented in TensorFlow. It can be implemented in other frameworks like PyTorch. So that's the major difference.
Okay, thank you.
Did you have to retain your language model with 40 gigs web data, or did you obtain the model from somewhere else and just fine-tuned it on your paraphrase? So GPT-2, OpenAI basically has open source these models. So it's these pre-trained models that are trained on Wikipedia text or any other corpus are publicly accessible. So what I did was I took that pre-trained model and then fine-tuned it on my paraphrase task. Okay, so next question. Do you observe a recommended ratio between the pre-trained model data size and the fine-tuning training data size to get the needed results? How did you evaluate the resulted sentences? Well, I really don't know, can't answer that question about the recommended ratio because I did use a pre-trained model, but I can get back to you on that after this call. How did I evaluate it? So I used there is a model called Universal Sentence Encoder that gives you sentence embeddings for the text that's outputted from the model. And if you pass that through a cosine similarity measure, then you can get how closely related your utterance and your paraphrases in semantic space. I also used Rouge ELF that basically gives me which is an indicator of syntactic diversity. So I used a combination of the two to see how well my model was performing. Do you think you could train a single model that works for multiple languages at once? Honestly, I haven't tried that, so I can't say much. But yeah, I really can't say much to that. But there are approaches that I've seen even in language translation where they do one-shot learning for both, like for translating different languages. So maybe the same could apply when it comes to paraphrasing. The next question. Sometimes punctuations and emoticons have meaning. Does your model take this into account? For my model, the objective was just to generate English sentences without emoticons or punctuation. So the data that I had was pre-processed and these were filtered out from that data. Why would this be a good for a chatbot if utterances that I get back are paraphrases? So when your chatbots deploy to production, different users have different ways of communicating with the chatbot. Some would have different ways of asking for the same thing. So for example, if your user wants to book a meeting room, they would ask, what are the availabilities of meeting rooms on this day? Or they could ask, I want to book a meeting room. So those are two different ways, but they're trying to get the chatbot to do the same thing. And so when you create paraphrases, you're able to cater to a larger audience and larger set of users who communicate to the chatbot in different ways, and your chatbot performs well. A lot more of the messages are understood by the chatbot. So the next question is, what's the most time-consuming piece of work in developing an end-to-end chatbot with your strategy? So Fatima, are you speaking of after we've integrated those tools into?
Yeah, I mean, no, in the process of developing the chatbot, which part did take most of your time? like intent detection part, generation part, infrastructure stuff, such as putting your chatbot on the cloud? Which part of the work was more time consuming?
I think the most time consuming was the designing the conversational flows and the intent identification part, and just making sure that the way the conversation's been structured, it provides a good user experience. I hope that answers your question.
Yes, thank you.
Did you deploy the model in the cloud? If so, did you find any limitations or lessons learned when deploying it, such as memory constraints? Currently, the model was not deployed on the cloud, so it was deployed on an internal GPU machine. And yes, GPT-2 has memory constraints. You should ensure that you have enough RAM and when you're basically hosting the model, because the model gets loaded into the memory as it's serving the users. How does BERT relate to the processes you have created? So BERT is another language model that you could use for text generation, and BERT can be used for a couple of different things, but when comparison to GPT-2, GPT-2 performs better because of the amount of data sets that the pre-trained model was trained on. And so that's what GPT-2, that's why we use GPT-2 in our paraphrase generation task as opposed to BERT. Is there a way to improve the relevancy results for the suggested utterances? So we could sort these utterances by doing a simple, getting some, like I said earlier, getting the sentence embeddings and then giving a score to each of the paraphrases and then sort them by that score. I think I've covered all the questions.
Yes, it looks like that's almost the last of the questions. If there is any last minute questions, please let us know. If not, thank you so much, Ayesha. This has been a great presentation, and just seeing through all the questions. I've been in about 5 workshops today, but it looks like you got the most questions so far. It's amazing. Thank you. So everybody, the presentation / video will be shared after the summit. Once again, you will be receiving an email from Hopin later today just to confirm your attendance for the summit for the next 2 days. Cool. Thank you so much, everybody. Have a good day.
All right. Bye. Thanks.